Hello everyone, welcome to Mass's class. In today's video, I will be discussing the kinetic molecular theory. This theory tells us how the molecules of a gas behave. In fact, it tells us how the ideal gas behaves. The theory states that, first, the molecules of an ideal gas exert no attractive forces on each other or on the walls of the container. Second, it states that the volume occupied by the molecules is negligible. This means that the molecules occupy almost zero volume. 3. States that the molecules are in constant random motion. They move in straight lines and they collide with each other and with the walls of the container. To help you visualize, shown on the right, this box shows you how the molecules actually behave. Collisions are perfectly elastic. What this means is that in the collisions, the kinetic energy is conserved. Fifth, the average kinetic energy of these molecules is directly proportional to the absolute temperature. The absolute temperature, in fact, is the temperature in degrees Kelvin. Now that we understood how molecules behave, we will go on to explain chemical reactions. In any chemical reactions, we usually have the reactants reacting together in order to form the products. What happens is that the bonds in the reactants break, and the molecules will rearrange themselves in order to form new bonds, which make the products. For chemical reactions to occur, the reacting particles must collide with each other, and they must possess sufficient amount of energy. To explain this further, we will go to the collision theory. In order to explain the collision theory, I want you to think of two people wanting to greet each other by simply shaking hands. First, they must collide in the correct orientation, so they must be facing each other. Second, they must possess the sufficient energy to actually shake hands. We call this energy the activation energy. If both these conditions are met and the particles are in the correct orientation with the sufficient amount of energy, we will have a successful collision in which products will be formed. Reaction rate. So the reaction rate tells us the speed of the chemical reaction, or how fast the reaction is actually going. The reaction rate mainly depends on the number of successful collisions. The more successful collisions there is, the higher the rate of reaction. Some of the factors affecting the reaction rate include the concentration of the particles, second, the temperature at which the reaction is occurring, third, the presence of a catalyst, and fourth, the surface area of the reacting particles. We will discuss now the factors affecting the rate of reaction in more details. So first we will look at concentration. If we have particles at high concentration, there will be more reacting particles. As a result, we will have more frequent collisions. And with more frequent collisions, we will have a higher rate of reaction due to a higher chance of successful collisions. Second, we will look at temperature. At higher temperatures, the molecules will possess higher kinetic energy. And with more kinetic energy, they will move at a faster speed. As a result, there will be more frequent collisions and they will collide with each other more. This will increase the chances of successful collisions. As a result, we will have a higher rate of reaction. Third, look at surface area. With higher surface area, we have a higher chance of collision for the reacting particles. As a result, we will have a more likely successful collision and a higher rate of reaction. Now we will discuss the catalyst. So, what is a catalyst? In fact, catalysts are substances that speed up a chemical reaction without being changed or used up themselves. They do that by providing an alternative pathway for the reaction. Catalysts will lower the activation energy, making it easier to react. So if we think back of the collision theory, then the two people can just high five instead of actually shaking hands. As you can see here in the graph, the red path is the path with the catalyst. It has lower activation energy, make it easier to react. Thank you for watching this video. I hope you found this useful. My name is Masal Rifai, and if you have any questions, please don't hesitate to contact me through my website. Thank you.